Right now, Earth is drifting through the debris of an exploding star. Tiny particles of that explosion are still moving through our solar system. Some of them even reached Earth. Scientists discovered them buried deep in the bottom of our ocean, which means a nearby star once exploded close enough for debris to reach our planet. That explosion happened about 2.6 million years ago. Inside those layers, they found something unusual, an isotope called iron 60. Iron 60 is extremely rare on Earth. That's because it doesn't last very long on a cosmic timescale. Any iron 60 that formed when Earth was created has long since decayed away. So when scientists find fresh iron 60 on our planet, it means it had to arrive recently, and there's only one place it can come from: exploding stars. When a massive star ends its life in a supernova, it forges heavy elements and blasts them out into space. Some of that debris eventually spreads across nearby star systems, including our own. For comparison, one of the nearest stars that could explode today, Betelgeuse, is more than 500 light years away. The star that exploded back then was somewhere between 150 and 300 light years. That may sound far, but in cosmic terms, that's extremely close. Supernova are amongst the most violent events in the universe. For a short time, a single exploding star can shine brighter than an entire galaxy. The explosion releases enormous amounts of radiation and high-energy particles. If a supernova happens too close to Earth, it could strip away parts of our atmosphere and flood the planet with dangerous radiation. Some scientists even think nearby supernova may have triggered mass extinctions in Earth's distant past. But distance does matter. The explosion that reached Earth was close enough for its debris to drift into our solar system, but far enough away that the planet itself survived. Instead of destroying life, the event may have weakened parts of Earth's atmosphere, possibly even thinning the ozone layer and allowing more cosmic radiation to reach the Earth's surface. That increase in cosmic radiation could have lasted for thousands of years. Most of life on Earth's surface would never have noticed, and that explosion may not have been the only one. Astronomers now believe our solar system is drifting through a vast region of space shaped by multiple ancient supernovae. This region is called the local bubble. It's a huge cavity in the interstellar gas surrounding our solar system, stretching roughly 1,000 light years across. Compared to the normal interstellar medium, the gas inside the bubble is extremely thin and incredibly hot. Scientists think it formed when several nearby stars exploded millions of years ago. Each supernova blasted material outwards, sweeping away the surrounding gas and carving out a larger and larger cavity. Over time, those explosions created the bubble our solar system now sits in. In other words, the space around us today was shaped by ancient stellar explosions. When that supernova exploded, Earth was already home to life. But the planet looked very different. This was around 2.6 million years ago, in the beginning of the Pleistocene epoch, when early human ancestors were just beginning to appear in Africa. The radiation from a nearby supernova wouldn't have arrived as a single blast. Instead, high-energy cosmic rays would spread through space and reach Earth over thousands of years. When those particles hit our atmosphere, they can create cascades of secondary particles that reach the surface. Some researchers think this may have slightly increased radiation levels on Earth for long periods of time, possibly affecting climate, cloud formations, or mutation rates in some organisms, but the evidence is still debated. What we do know is that the debris from the explosion eventually settled onto Earth's surface and remained there for millions of years, waiting to be discovered. The universe doesn't keep its distance from us. Stars are constantly being born, evolving, and eventually dying. Sometimes those deaths happen close enough to leave a mark on our planet. The supernova that scattered iron 60 across Earth's oceans exploded long before humans existed, long before our species even appeared. Yet the debris from that explosion eventually reached our world and settled quietly onto the ocean floor. Evidence that our solar system once passed through the aftermath of a nearby stellar explosion. A reminder that Earth doesn't exist in isolation. We live inside a galaxy that's shaped by events far larger than our planet, and sometimes the universe leaves behind clues that we can only discover millions of years later. That's a fact.